Good day everyone. Our topic for today is all about application of fundamental counting principle and permutation. So let's start. Now solve for the following. Let us answer number 1. Given the digits 0, 1, 2, 3, 4, 5, 6, 7, 8, and 9, letter A, how many different arrangements can be made on the digits 0, 1, 3, 5, 7, and 9 without restriction? Letter B, how many 4-digit odd numbers can be made from the given digits? Now, let's have the solution for letter A. So, yung goal natin dito sa letter A is to find how many possible arrangements can be made on the digits 0, 1, 3, 5, 7, and 9 without any restriction. This is under permutation. In this case, yung n natin, since meron tayong 1, 2, 3, 4, 5, 6, yung n natin is 6 kasi meron tayong 6 digits. Next, i-arrange natin silang lahat, so yung r natin is also 6. So we can use n permute r or simply n factorial over n minus r factorial. In this case, yung n natin ay 6 and yung r natin is also 6. So we have 6 factorial over 6 factorial minus 6 factorial. Now, sa denominator, meron tayong 6 minus 6 or simply 0 factorial. So this is equivalent to 6 factorial or simply 720 different arrangements. And we're done. Now, let's move on to letter B. Letter B, how many 4-digit odd numbers can be made from the given digits? Sa ganitong klase ng problem, meron tayong mga kailangang i-consider. So, yung una, meron tayo itong 4-digit number. Anong ibig sabihin? Yung first digit natin ay hindi dapat mag-0. Now, anong mangyayari kapag yung first digit natin ay nag-0? So, hindi na siya 4-digit number. Siya ay 3-digit number na lang. Nakuha? Kaya yung first digit cannot be equal to 0. Okay? Next, yung odd or yung odd number. Kailan ba siya nagiging odd number? Kapag yung last digit niya is an odd number. Halimbawa, yung nasa huli ay 5, yung nasa huli ay 7, 1, 9, and so on and so forth. Now, dito, uunahin natin sagutan yung may mga restriction. So, unahin natin yung last digit. Now, sa last digit, ilan yung pwede nating ilagay? Para siya maging odd, kailangan odd digit din yung nandun sa last digit. Ano-ano ba yung mga odd digits natin? Ito sila. We have 1, 3, 5, 7, and 9. So, ilan yung option natin para dun sa last digit? So, we have 5 options. Kasi meron tayong 1, 3, 5, 7, and 9. 5 lang yung pwede nating ilagay dun sa last digit. Now, punta tayo dun sa first digit. Yung first digit natin, bawal maging 0. So, anong ibig sabihin? Yung option lang natin para dun sa first digit must be 1, 2, 3, 4, 5, 6, 7, and 9. So, meron lang tayong 9 options para dun sa first digit natin. Kasi bawal ngang mag-0. Now, how about sa second digit natin? Meron ba tayong restriction dito? And the answer is wala. Therefore, pwede natin gamitin lahat ng ating digit. So, ilan lahat sila? We have 10. Sa next digit natin, ganun din. Wala din tayong restriction. So, pwede nating ilagay yung 10 digit natin. Now, according to fundamental counting principle, we have a total of 9 times 10 times 10 times 5 or simply 4,500 different odd numbers. And we're done. Now, let's move on to question number 2. Joy has 4 different levels of mathematics books and 7 different books in science. If she planned to arrange them in a shelf, determine the number of ways she can do it. If, letter A, there's no restriction. Letter B, math books on the left and science books on the right. Letter C, the books on the same subjects must be kept together. Now, let's have the solution for letter A. Question sa letter A, determine the number of ways you can do it if there's no restriction. Now, ito ay under ng permutation. So, we have n is equal to 11. Bakit 11? 4 at saka 7. So, combine na. So, wala kasing restriction. Next, ilan yung i-arrange natin? Must be 11 din. Kasi silang lahat. So, we have n permute r or simply n factorial over n minus r factorial. This means we have 11 permute 11 or simply alam natin ito ay equivalent sa 11 factorial. Now simplify, we get 39,916,800 800 different arrangements, and we're done. Now let's move on to letter B. Letter B, math books on the left and science books on the right side. So kunin natin lahat ng math books, dito siya sa left side, and science books, dun tayo sa kanan. Now, since yung math books natin ay nandun lang sa kaliwa, so papalitan lang tong apat na to at hindi sila lalagpas dyan sa kaliwa. Okay? So hindi sila mapunta dun sa kanan ng science books. Okay? So magpapalitan silang apat, ilang ways natin pwedeng gawin yon? Since apat na magkakaibang math books yan, so meron tayong 4 factorial different ways. Now, yung science, ganun din yung scenario. Dito lang din sila magpapalitan dito sa may kanang bahagi. So, hindi sila pwedeng mapunta dun sa kaliwa. So, ilang arrangement nila pwedeng gawin yon? So, meron silang, since 7 sila, so we have 7 factorial ways. Now, according to fundamental counting principle, yung total natin must be 4 factorial times 7 factorial. Or simply, 120,960 different ways. And we're done. Now, let's have the solution for letter C. The books on the same subject must be kept together. So, we have 4 na math and 7 science books. Now, ilang ways ulit natin pwedeng i-arrange tong 4 since magkakatabi sila, hindi sila pwedeng maghiwa-hiwalay. Meron tayong 4 factorial ways. Next, lahat ng science, meron tayong 7 factorial ways. Next, igugrupo natin sila. Bakit? Kasi hindi sila pwedeng maghiwa-hiwalay. Ang sabi kasi doon, same subjects must be kept together. So, hindi sila pwedeng maghiwa-hiwalay lahat ng math at lahat ng science. So, gagawin natin silang isang grupo. Like this. Grupo ng math books and grupo ng science books. Now, since pwede pa silang pagpalitin ng pwesto, yung math mapupunta sa kanan at yung science mapupunta sa kaliwa, so meron tayong 2 factorial ways para i-arrange sila. Okay? Now, according to fundamental counting principle, yung total na natin ngayon must be 2 factorial times 4 factorial times 7 factorial. Therefore, we have 241,920 different ways para i-arrange lahat ng math books na magkakasama at lahat ng science books na magkakasama. And we're done. Now, let's have the question number 3. In a certain photo booth, a man, an old man, 5 male students, and 6 female students are asked to line up for a photograph. So, pipicturean sila. Determine the number of ways they can line up if may condition. Letter A, there's no restriction. Letter B, the 2 men stand together. So, dapat magkatabil palagi yung man saka yung old man. Okay? Letter C, the 2 men don't stand together. So, suppose magkagalit sila. Ayaw nila magtabi. And letter D, all female students stand together. So, yung mga babae magkakasama. Now, let's have the solution for letter A. Ito yung pinakamadali kasi. Ang kailangan lang natin dito, bilangin ilan lahat sila. So, meron tayong man, meron tayong old man, 2 na. 5 male students, meron tayong 2 plus 5, so we have 7. Plus 6 female, meron tayong 13. So, yung N natin must be 13. Next, i-arrange natin silang lahat, so yung R natin is also 13. So, therefore, we can use and permute R. So, we have N factorial over N minus R factorial, na alam natin na ito ay equivalent sa 13 permute 13. Or simply, 13 factorial different ways. Or simply, we have 6,227,020,800 different ways. Ito yung number na kung saan pwede silang lumine up sa photograph without restriction. Okay? Next, let us answer letter B. The 2 men stand together. So, ibig sabihin, yung man saka yung old man ay magkatabi palagi. Hindi sila pwedeng maghiwalay. Okay? Now, gawa tayo ng representation. Yung 2 man, gawin natin siyang man 1 saka si man 2. So, yan yung old man saka yung man. Next, yung 5 male student, ito ay MS1, MS2 hanggang MS5. Male students. Next, we have female students, FS1 hanggang FS6. Now, since yung old man at saka yung man ay palagi magkatabi, gagawin natin siyang isa. O igugrupo natin sila. Anong ibig sabihin kung bakit natin sila ginrupo, yung dalawa? Tingnan nyo mabuti. Kapag inilipat natin si M2, kasama niya palagi si M1. Kasi nga, grupo sila. Nakuha? Now, ilan lahat sila? Yung M1 and M2, bibilangin natin sila as 1. So, 1 plus 5 is 6. Plus 6, we have 12. So, meron tayong 12 factorial different arrangements. Kasi pwede silang maglipat-lipat. Yun nga lang, pag lumipat yung si M2, kasama niya si M1. Kasi nga, grupo sila. Next, tandang mabuti na yung M1 and M2, pwede pa yung magpalit. At ibang arrangements na naman yon. So, ilang arrangements yung pwede nilang gawin. So, since dalawa sila, meron tayo ditong 2 factorial ways. Therefore, according to fundamental counting principle, we have 2 factorial times 12 factorial different ways, or simply, we have 958,003,200 different ways na pwede natin silang i-line up sa photograph na kung saan yung dalawang man ay nakatayo ng magkasama or magkatabi sila sa picture. Okay? Now, let's move on to letter C. Letter C naman, the two man don't stand together. Kanina, yung dalawang man ay magkatabi. Ngayon, magkahiwalay. So, paano natin ito ngayon sasagutan? Now, i-analyze natin yung scenario. So, una, nakuha na natin yung arrangement nila without restrictions. So, nakuha natin yun as 6,227,020,800 different ways. Next, nakuha na rin natin yung number of arrangements kung saan magkatabi yung dalawang man, si old man at saka yung isang man. Nakuha na natin yun as 958,003,200 ways. Now, imagine, papipilahin natin sila sa isang pila at pipicturean natin, dalawa lang yung posibleng mangyari. Una, the two man stand together. So, magkatabi sila sa picture. And yung pangalawa, the two man don't stand together or magkahiwalay sila. Yun lang yung posibleng senaryo. Now, ang tanong, paano natin makukuha kung ilan yung arrangement kung saan yung dalawang man ay hindi magkatabi sa picture? Simple lang to. Meron na tayong total. Meron na tayong yung magkatabi sila. So, ito ay simple subtraction na lang. So, we have 6,227,020,800 minus yung magkatabi sila. So, we have 958,003,200. Now, pag sinubtract natin to, makukuha natin yung number of ways kung saan yung dalawang man ay hindi magkatabi sa picture. Okay? So, subtract natin. We get 5,269,017,600. Therefore, we have 5,269,017,600 different ways kung saan yung dalawang man ay hindi magkatabi sa picture. And we're done. Now, let's have the solution for letter D. Letter D naman, all female students stand together. So, lahat ng mga babae ay magkakatabi sa picture. So, represent ulit natin yung scenario natin. So, we have M1 and M2, yung dalawang man, isang man saka yung old man, yung 5 male students, and yung 6 na female students. Now, yung 6 na female students, i-group natin. Now, bakit natin sila i-grupo? Para kapag inilipat natin si female 1, kasama niyang lilipat si female 2, female 3, female 4, female 5, and female 6. Okay? Or simply, yung 6 na babae gagawin nating isang grupo. Nakuha? Now, ilan na lang yung i-arrange natin? So, we have 2 plus 5 plus 1. Kasi ginawa natin siyang isang grupo na to. In short, ilan na lang i-arrange natin? So, meron tayong M1, M2, meron tayong dalawa. MS1 hanggang MS5, meron tayong 5. 2 plus 5 ay 7. And itong grupo ng babae, ginawa natin siyang isa. So, we have 7 plus 1 or simply 8. Therefore, meron tayong 8 factorial ways na i-arrange silang lahat. Now, tandaan na yung 6 na female students ay pwede pang magpalit-palit ng posisyon. Now, ilang ways nila pwedeng gawin yon? So, we have 6 factorial ways. Now, according to fundamental counting principle, we have 8 factorial times 6 factorial different ways or simply 29,030,400 different ways nila pwedeng gawin yon. And We're done. Now, let's move on to question number 4. So we have, during the live concert of Morissette Amon, 4 married couples bought 8 seats in a row. If each couple will be seated together in which the husband is at the left of the wife, in how many ways can they be seated? Now, i-represent natin yung scenario. We have husband 1 and wife 1. So, meron tayong 4 na husband and 4 na wife. Natandaang mabuti na ang sabi dito sa problem ay yung husband ay nasa left nung wife. So, hindi na pwedeng magalaw yung arrangements. Okay, so anong ibig sabihin nun? Igugrupo natin sila as 1. Okay, so meron na lang tayong 4 na grupo. At meron na lang tayong 4 na i-arrange. Now, since hindi gagalaw yung husband, andun lang siya sa kaliwa ng kanyang wife, meron na lang tayong 4 na grupo na i-arrange. Therefore, we have 4 factorial different arrangements or simply 24 ways and we're done.